talk is from Omprakash, Bombay, Holi, and he is from Basaveshwar Engineering College, Karnataka, from Department of Civil Engineering. He is going to talk about sustainable waste disposal system for a village, Agavati and Baglakote.
Very good afternoon to all the dignitaries and the delegates. I'm Omprakash. So today here I am to present my topic, my paper, research paper on sustainable waste disposal system for a village which is Bhagwati in a district of Karnataka called as Bagalkot. So I've done this research under the guidance of Dr. Veena Sargami and co-guided by Dr. Jayalata NA. I'm from Basaveshwar Engineering College, Bagalkote. So these are the list of contents that I've followed. So as you all know, wastewater treatment is one of the very much emerging technologies, and all the speakers and big delegates who have spoken about this, from these recent studies. So floating wetland solution is a engineered approach where I've considered for this paper presentation. So these are the works that I've carried out. So basically floating wetland management system where I've used two plants for the wastewater treatment. That is, one is Chrysophobin zizonoids and one is vetiver grass. So basically we have done a case study for a village which is called as Bhagwati. There we have a pond which is completely polluted. So all the waste from the village completely come and they get dumped into the particular pond. So including all the, say for example, soap waste, other things, everything, all the cow dung, all the kinds of waste are directly being dumped inside that wastewater pond. So in order to treat that, we have come up with this floating wetland. So we have also designed a solid waste management technology for that particular village, where we have designed the vermicomposting beds will be showing in the next slides. So this is the study area that we have considered for the analysis. So this is Bagalkot district, which is situated in the North Karnataka, and this is Bhagwati village, and this is the aerial view that you can see from the Google Earth. So this is the lake which is contaminated with algae and other things. So the dissolved oxygen content is very much less here, and it's highly polluted. So in order to treat this wastewater pond, we have come up with this technology of wastewater treatment. So initially we have designed a lab scale management inside our college premises. So here you can see the lab scale wetland construction which was constructed in the behind area of our college. So these are the vetiver grasses that we have considered. So basically they have a very long roots which are responsible for the phytoremediation, that is uptake of organic and inorganic matter from this wastewater which we have collected from the pond. And these you can see they are Azolla pinnata weed. So basically these two consideration of plants, they are very much essential for the wastewater treatment. So initially we have done the characterization for the physicochemical characterization of this wastewater. So analyzing all the different parameters like nitrogen, phosphorus, BOD and COD removal. So these are the permissible limits, and these are the initial concentration before the treatment that we have got it here. And these are the final concentration that we have obtained after 40 days of treatment period for the Chrysophobin zizonoids, which is also called as vetiver grass. And the removal of efficiency is what we have obtained as 66.67 for nitrogen. For phosphorus is 50%, which is quite significant. BOD is 50% and COD is 39.13 for 40 days of treatment for the Chrysophobin zizonoids, whereas 47 days of treatment period was considered for the Azolla weed. So these are the removal efficiency. So basically by comparison of both the plants, we can say that vetiver, that is Chrysophobin zizonoids, has shown the significant results in terms of the organic and inorganic matter, nitrogen, phosphorus intake. So I would say that Chrysophobin zizonoids has played a very significant role in the toxicants removal. So these are the variations of BOD and COD concentration, both in case of vetiver as well as Azolla. So there is a good amount of reduction of BOD initially in the initial 2 to 3 days after the treatment, and then there is drastic reduction. Till here there is a drastic reduction, and after that the amount of reduction of BOD content in case of vetiver is quite normal, and it reaches stagnant. And we can also see the other parameters like BOD of Azolla, COD of vetiver, COD of Azolla as well, which initially has a drastic decrease in the initial few days, that is a week and 10 days of treatment, and later they become almost stagnant and they are constant. So these are the variation of nitrogen and phosphorus concentration in that particular wastewater concrete rings that we have considered here. So nitrogen and phosphorus removal also showed the significant amount of reduction. And here you can see there is quite a constant reduction. There is almost a stagnant reduction of almost 12 to 14 mg per liter of phosphorus reduction that is constant after 30 days of treatment in case of azola. So these are the removal efficiencies that we have considered after the physicochemical characterization. So quite significant reduction. And we have also designed the vermicomposting technology for that particular village, where we have drawn the maps and we have considered the disposal bins for the disposal of the waste, and the vermicomposting units are being designed in this way. So initially we have gone to that village and collected the various data related to that village, like how many people stay there and the health conditions and hospitals, other things. So how we can treat this particular village efficiently is what we have considered. So it has a population of 3069 and where 581 households were considered. And so we have calculated the total waste generated by person per day into population is 1061.87 kg per capita per day. So this is what we have got it from the data from the village panchayat, that 75% of it is organic waste and 25% of that is inorganic waste. So we have considered the bed with the dimensions 22 into 10 into 10 centimeters, which has 1 ton capacity. And this is how we have designed that. So the length of this particular bed, 4-bed consideration, which we have considered here, is 3 meter length and 1 meter in width. And the brick sizes are 22 into 10 into 10 centimeters. So we introduced red worms inside that particular vermicomposting beds, and we added the like organic and inorganic matter, and like 40 to 45 days of they were left like that. And 1 ton of organic waste, that is 0.8 ton of vermicomposting, was generated at the end. And this is how you can see the practical thing which was taken place here. And we also conducted the awareness program at the Bhagwati village, where we told the people about how effective is the sustainable waste disposal system we can construct for that pond. We educated them about how they can implement that. We have given the proposal for the panchayat, and we have suggested them to continue it for a longer period of time in order to improve that particular village. We have also told them about how to maintain the cleanliness, and we have also educated small children and other people nearby to maintain the cleanliness at that particular village. So at the end, we can say that there are significant reductions that we can observe here. So BOD 50% reduction, COD, these are the results that we've already obtained. So with that, we can conclude that Chrysococcus zizonides has shown a significant treatment, and there are a lot of economics as well as since this is a low-cost treatment plant. So instead of using high-cost sewage treatment plant, we can use this to a larger scale and implement it in more number of villages so that it can be sustainable as well as eco-friendly. I would like to thank my guide, Dr. Veena Sargave and Dr. Jayalata Ene, for guiding me. And I would like to thank my college for giving me this opportunity. And I would also like to thank my lab assistants and the organizers of IIT Bombay National Environmental Conference 2024 for giving me this opportunity to present my paper. These are some of the
Thank you. So with this, we'll move to the last talk of this section, which is by Nitesh Premchand. He is from Department of Civil Engineering, National Institute of Technology, Mizoram. He is going to talk about comprehensive study on biohydrogen production technologies and their environmental effect to life cycles.